I would like to introduce you our next speaker, Roberto Cortez, who is a passionate Java developer. He has more than 10 years experience in Java programming. He is very much involved in the open source community and wants to spread the knowledge about Java and technologies. He's a regular speaker at conferences, Java 1, DevOps, Devenu, JFocus, and of course, Java Summit from Bucharest Technology Week. He leads the Coimbra Java user group.
Yes, Coimbra.
Okay, thanks. I was afraid of pronunciation.
That's fine.
And he founded JNation conference in Portugal. He comes here telling us that he can prove to develop enterprise application with just a few lines of code who can run on Raspberry Pi. I would like to automate my entire farm with Raspberry Pis, so I would like Roberto speak with your applause.
Okay. Hi, everyone. Thank you so much for having me here. It's really a pleasure to be here with you guys. I hope they're not going to be too much boring, especially because after lunch, people like to go to sleep. At least I do. Anyway, we don't have too much time, so I'm going to try to do this a little bit quick, so let me know if I'm going too quick. Also, I'm going to do a couple of demos, so let me see here. Can you guys see this properly? Okay, so let's leave it like that. Okay, so I'm going to skip that. Anyway, so our agenda for today, we're going to talk a little bit about microservices and what is Microprofile. We're going to have a look about Microprofile specs overview, and we're going to do a bunch of demos regarding all of these specs, and we're going to talk a little bit about Microprofile future. But before we dig into our session, who's doing microservices? Yes. Who likes microservices? Really? Come on. We are in a safe environment here. You can tell me if you like microservices. Okay, now I see less people raising their hands. So why do people mean about microservices? So those are some of the few things that I heard people saying. But usually when I want to hear about something or I want to learn about something, what I do is I go to Twitter and I start asking people over there. And these are some of the responses that I got. Right? Okay, if you cannot build a monolith correctly, why do you think putting a network in the middle will help? Say microservice one more time. One day, microservice will share some list we'll call servlets. You're not GAFAM. You may not need that. GAFAM is Google, Amazon, Facebook, Apple, and Microsoft. Architect's dream, developer nightmare. Okay. Anyway, these kind of architectures came. People started to use it. It was heavily popularized by Netflix. And the idea was to help developers develop new features quicker, have a smaller agile teams. And for me, that was the most obvious and the thing that I really enjoy the most of these kinds of architectures is it allows you to scale your service independently. So especially when you're building software that has different requirements on different services, this is really a must when you're doing these kind of architectures. Still, there is challenges over here, and that's why, in my opinion, doing this kind of architecture of microservices is hard. You have scalability problems. There is a cost reduction. You have to handle resilience, right? Because one thing, having a monolith where all the service is going, at least if one thing is down, everything is down, so you're not going to have much issue over there, right? Now, if one service is down on your microservice architecture, it might affect all the others, which are still running. And sometimes I believe it's better to have everything down instead of having something that it's up, but it's not actually doing something. And then you have to deal with stuff like monitoring, and you have to deal with stuff with security. So it brings a couple of extra challenges that we actually haven't learned about them in the last 20 years. We only start learning about them in the last 3, 4, 5 years. So a lot of the tooling, a lot of the infrastructure, a lot of the libraries were not even there yet. And especially in Java, we didn't have actually something that helped the developers develop microservices in a proper way. So that's why this new project called Microprofile came to existence, and the idea is this is actually enterprise Java to help Java developers develop microservices. So who heard about Microprofile before? Okay, a few. That's not that bad. Spring Boot? Okay, so now we're talking. So Spring Boot is not Microprofile, even though they are very similar. So you can think about Microprofile as another tool or another framework or another set of libraries in your chain that help you develop microservices. So we're going to have a look. We're going to do a deep dive on some of the stuff that you're able to do with Microprofile, and maybe you'll see that it might help you on stuff that you're doing right now. Okay, so what is actually Microprofile? So the initial version of Microprofile came on 2016, and it was compromised with only 3 implementations. So CDI, JAX-RS, and JSON-P. Are you guys familiar with all of these specs? Yes? So those are pretty standard specs on the E-world, and some of them are even used on Spring Boot as well. And one of the ideas of Microprofile is allow you to have application portability across different runtimes. So you're able to pick up a Microprofile application and run it on let's just say, Tommy, which is Enterprise Edition version of Tomcat, or you can run it on Wildfly, or you can run it on WebSphere Liberty, or even any other server that supports Microprofile. The same thing that you will do with your EE application that you developed like 10 years ago. Now, currently, Microprofile is on version 2.2 since February 2019, so a few months ago. And let's just look on how much things we accomplished over these 3 years. So we added a configuration spec, fault tolerance, jot propagation, health check, metrics, open tracing, open API, and a type-safe REST client. Wow, for me, that's wonderful. I mean, all of this work that we were able to accomplish and gave all of these specs for people to help them develop these kind of architectures. There's also reactive streams spec. We're not going to demo it here, or I'm not going to do it here today. But at least you know that it's this, and that's what's released standalone, so it's not part of the Microprofile bundle, but it lives on its family. So you can also see not only we added CDI, JSON-P, and JAX-RS as the first few specs, but also JSON-B, which is JSON binding for Java objects, also came to the spec when EE8 came out. Then you have all the 8 other specs that I mentioned before, and you can also figure out that there are a lot of other versionings. So of course, all of them started at version 1.0. Now you'll see config is already on version 1.3, OpenAPI on 1.2, or there's already a version 2.0 for fault tolerance. So you'll see not only these specs have been created and you have an initial implementation, but they also been evolving in the last 3 years. And the reason for it is because in this microservices world, things evolve super quick. So the idea with the Microprofile project is that we evolve as fast as possible to give to the developers the latest APIs, the latest things that they need to develop these kind of architectures. So why is Microprofile? So every time you wanted to develop an enterprise application, you either go use EE or Spring. So I know there are a lot of Spring users over here, right? Yes? And what about EE users? Okay, a few. We're not going to go into this whole debate between EE and Spring. That's been done a lot of times. My personal opinion is that you can use both. I've done it plenty of times, and that works very great. But the real problem here, there was a negative perception towards the EE technology, and the reason for it is because it's been slow. So if you look on when E8 came out, it was around 2017, I believe. The E7 came on 2014, so there is a huge gap between years where nothing gets released, and then the specs that actually came out on the E world, they were not actually helping developers on the microservices world. So in my opinion, EE was not really prepared for that. So Microprofile ends up being a set of standards to help you develop microservices. And one of the things that I really enjoy about this process is on Microprofile, you have a set of a community where you have multiple organizations, a set of individuals, and vendors that are working together to actually come up with a proper spec and help you out with all of these. So think about something else, which is Microprofile is not EE, or now Jakarta EE if you've been following all the renaming brand thing. So it's a completely separate thing, but it can work together with EE. So that's just to make it that clear. Now, who's involved in Microprofile? So now you'll see that companies, big companies like IBM, Red Hat, Oracle are involved in that. And then you have some mid-sized companies like Hazelcast and Lightband. You also have Java communities like Java Brazil, which is one of the biggest Java communities in the world. And also the London Java community, which is here, of course, in London, which is probably the second biggest. And also a set of individuals. So, and the idea here is that you have all of these companies, all of these communities, all of these individuals working together, collaborating between each other to help you out with all of these. So, of course, there are already a lot of Microprofile implementations out there. So you have Payara Micro, you have Wildfly or Wildfly Swarm, or actually Thorntail from Red Hat. You have IBM Liberty. You have Tommy. So there are plenty of implementations that you can pick to use. And again, as I told you before, they are compatible across all these runtimes. So if you have something that's running on WebSphere Liberty, you can pick up your package, and then you can run it on Tommy. It will work exactly the same way because it's the same standard. They are the same specs. So that's the idea. So the one that I'm going to actually show today, it's about Tommy. So who heard about Tommy before? Okay, a few. And about Tomcat? Yes, everyone, of course. So Tommy is actually Tomcat plus Java EE. So that's where the name comes from, Tommy. So what happened on the Tommy project, which is an open source project on Apache, it was built about the OpenHAB community to actually have an HAB implementation when the HAB spec came out. The project later evolved, and then it became Tommy, which basically what we do at the project, we pick up Tomcat, and then we add all the libraries that require to run EE, plus we run the TCKs on that, and then we have a certified version of Tommy, which runs all the EE stuff. Now, Tommy itself also is a Microprofile implementation. So currently it's supporting Microprofile 2.0, but work is being done to support 2.2. There is not that many differences between 2.0 and 2.2. There are just a few minor things. So it should be done really quick. Actually, I think that there is a release going at this point that's going to help on this right now. Okay, so let's see how the first Microprofile app looks like. So I'm going to skip these ones, CDI, JSONP, and JAX-RS, because you've seen those plenty of times. So let's look at some code. So we have an application scope bean, we have a path, which basically is a book resource. It's injecting a book bean, it's trying to find a book bean from a bean, and then it returns that book on a response object. So who's familiar with that code? Have you seen that code before? Or something at least similar? Yes, most of you. Okay, congratulations, you have the first Microprofile app running. All right? So you have that code, you already have your Microprofile app over there. The only difference is that you don't have a library for it, because this is just the standard or the initial stuff. Now, the most interesting thing is picking up what you already have and now start evolving it with all the other specs that I mentioned before. So let's see how we can start evolving our Microprofile app. Okay, let's start with Microprofile configuration. Okay, so on configuration, so every application needs configuration bases to change their behavior on runtime, right? Especially now with all of the things that we have that runs on Docker, that runs on Kubernetes, that run on the cloud. You pretty much want to change endpoints locations, you want to change file locations, right? Who's familiar with that? So all of you pretty much have some kind of configuration on your project, right? Yes? Wonderful. So the idea with microprofile config is that you're able to change the configuration and change the behavior of your application during runtime without having to repack or redeploy your application. So microprofile config was actually based on a few other projects called Apache Delta Spike, Apache Tamai, and Sabot. I'm not sure if you heard about those before, but if you heard, then what you'll see over here is very, very similar. Now, on configuration, it actually supports CDI, or you can just execute it as standalone spec. So you don't even need a container for this. You can just pick up the microprofile config lib, add it to your project, and you can use it straight away without as a standalone jar if you want, if you like it. It has support for default values, and it also supports conversion for the most common Java types. So you're able to convert things from strings, objects, longs, and even supports optional. Now, let's see how that works. So we'll just do add inject, and then we'll use add config property. So those two annotations, on config property we have a name. We pass in the configuration name for that config property, and you can set up a default value. And congratulations, you have your first config. It's that easy. Now, if you want to do that if you don't have a CDI environment, and if you want that as a standalone, then you can use that API. So you have an object called config provider. You can call get config. You'll get the config object back. And now from the config object, you'll do config get value. You pass in the property key name, and you say what's the type that you want to convert it. So it can be, for instance, if that one was an actual number, so that's just a number API, which is an endpoint, you can just map that as an integer, and it will just auto-convert it to an int. The same thing over here. So here you don't have a conversion because it will automatically detect the type from your declaration. So and now how this actually works. So config already packs with free default what we call config sources. And a config source is something where we're going to retrieve the config values from. So they are free. First one is you have a file that goes into metainf called microprofile config.properties, and you can set up the configuration over there. And then you can set it up as a system properties. So when you start up your Java runtime or your Java application, you can just pass them as a -d and the configuration name. Or you can set it up as an environment variable. So you just do an export on your actual bash or whatever system you have, and you can read this environment variables from the file system or from the operating system, which is actually great when you're running on Docker containers, because you can set up all the configuration on the Docker image run. Not only that, it actually allows you to plug in your own config sources. So you can create your own config source. You might want to retrieve config information from a database, from another REST endpoint. You can just use your imagination, right? So let's go and do our first demo over here. So let me kill that one. Okay, so you guys able to see this, right? I asked that before, so I'm just going to do a clean here. So that's like that. So that's that. Oops. So that's the shorthand for Maven clean install no test. So what I'm going over here is just building a project, and that project as a, let me show you that here very, very quick. So it's just a microservice that's called number resource, and that number API. And what number API does is actually generates a random number to fill in an ID for another application. So every time I require an ID, I go here, I retrieve the number, and retrieves the number, and that's it. So you'll see there's a bunch of annotations over here, and I'll go for that in a sec. But we'll see, we have here's a number. I even set up like a timer over there to have a delay because generating a number is a heavy operation, right? So generate a math run doesn't really matter. And now I can run this in two different ways. I can use the Tommy Maven plugin, but also when I run this with my build, and Tommy Maven plugin can also generate a fat jar, and the same thing as you do with Spring Boot. So I can run this as a Java jar target number API.exec, and now it will run my application. Okay, so I have my application running. I can come now over here. I'm going to do a curl so I can retrieve a number. And I run it like that, so I get that number. Let me increase that a little bit. Okay. So, of course, if I call this, I'll get different numbers, so nothing out of the ordinary. So now one of the things I'm going to do is I'm going to kill this application, and I'm going to export something that I call generation prefix. So if you notice over here, I have a config property called generation prefix. I injected it, call it with a generation prefix value. Default value is UN. And that one is actually used over here to generate the random number. So if you notice, the ones that I was generating generate with a BK dash. So let's do it with the MV. So I do an export with MV. Now I'm going to run directly with the Maven plugin instead of doing the fetch jar. So that also works. And if I do a curl over here, now I'll get an MV. Wonderful, right? And 25 minutes in the talk, and that's what I was able to accomplish. Okay, let's try to do a few things more interesting. So that's config. So I'm going to show you a couple, something here super quick. Actually, that doesn't show that well. Let me see if I can. Are you guys able to read this? Yes. Okay. So that's a config source. That's called the database config source. And what I'm doing is actually reading my configuration from the database. So you'll see I have a few tables called configurations. I read them from here. And then what happens is you have this ordinal over here that what's going to do is going to set the priority in which the config source is going to be loaded. So as you mentioned before, you have multiple config sources. There's already 3 that comes with you by default. So what's going to happen is all of them have a priority. And whenever it tries to search on a config source, if it doesn't find that value, it's going to fall back to the other one. If it doesn't find the value, it's going to fall back to the other one, and so on and so forth. That's why, if you see on my code, I have my number resource over here with, not that one, with a default UN. But actually, the one that I've seen calling first was actually returning a BK. And you'll see here that on my database, I have a SQL that actually have a BK over here. And then what I've done is I override that value using the environment variable. So those are a few things that you can do with config sources and configuration. So next, we're going to talk about microprofile fault tolerance. And this is probably one of my favorite specs. So microprofile fault tolerance allows you to define different strategies to guide the execution of a piece of logic. This is heavily inspired in Estrix and failsafe. So if most of you are Spring Boot users, you're probably familiar with those, right? And it does support async and async execution for all of these. Now, fault tolerance, there is a dependency on CDI, so you do have to execute them on a CDI container, because all of the execution logic is handled using interceptors, but you can use it on any business metric any business method that will go on your CDI logic, and it does integrate microprofile config and metrics that we're going to see later. Okay, I have demos for all these, but I'm not going to do all of them. So but at least you'll see what you can do with fault tolerance. So timeout. So timeout allows you to have a timeout on a business logic method to say, oh, if this method doesn't return in 1 second or 500 milliseconds or whatever configured time you have, it will return as a timeout exception, and it won't even let the method to complete. So it's useful when you're calling other services might be slow and you don't want to wait for them and you want to time them out and do something else. So retry allows you to execute the same operation again. So you can specify different criteria how to do retry, and these can also be useful. Let's just say you have a network glitch and you're not able to reach your service, so maybe you can do a retry and then you recover from the glitch and then you're able to execute the service again. Fallback. So fallback, it's something you can invoke if the original execution fails. So I'll just say invoke a service fails, then you can invoke that logic, and then you have something else. So in this particular case, the one that I'm going to show you is I don't have my number API working, and I'm going to fall back to a different number. So circuit breaker. Circuit breaker is one of the most interesting things, and probably you heard about those before. It allows you to prevent repeated failures, right? Let's just say you have something that's failing or a service that's failing. I'm pretty sure that if you keep trying, that service is not going to help these recover, right? So the idea with circuit breaker is that you may be able to fail fast and then open this, what we call open the circuit, so you can redirect the execution to logic somewhere else, and then you can retry from time to time to see if that service is up, and then if it's up again, then you'll close the circuit, and then you'll redirect the traffic again to the original one. And for me, this is useful for you to protect the services, right? Especially, again, if you have like a very slow service and you're hammering it, it's not going to help if you keep hammering it all the time. Bulkhead. So on bulkhead, allows you to limit the number of concurrent requests to a certain service. So let's just say you have a service, you only want to have 3 concurrent requests, so you're able to do that with bulkhead. You also can set up queues. So you have 3 concurrent requests and a queue of 3 or 4 that will wait until there is an available executor. If every executor, all the queues is full, then it will just return immediately with an exception. So a few demos here really quick. So let's see. Now I have, let me search. So what I'm going to show over here, not that one, book, okay, retry. Okay. So now I have a book resource, and the book resource is this one over here. So this is another service that I'm using, and the book resource, what it's doing is calling the number API to retrieve an ID to create a book. So if you notice over here, I'm actually changed a little bit the endpoint. So instead of calling number API, I'm calling book API, and then /book/number is going to call number API under the covers. So if I call that one, so I got the number, that's fine. If I called the fallback, I have the number, that's fine. So what I'm going to do here is I'm going to kill the number API, and I'm going to call fallback. Now I got the fallback number. But if I call number, I don't have anything. Actually, if I'll do a -v, I get the 500, right? Because if I go here and see the logs, then I'll see that there's some exceptions over here, and most likely is not connect or something like that, so connection exception. That's because my service is not running number API, but still I have a fallback, and at least it allows me to keep generating numbers. At least I'm not my service is not completely down. Maybe then I can have an async process that go on all the IDs and update them to the right numbers later. You get the idea. So I'm now going to do the retry. So on retry, so not that was no. So let's retry. So let's kill that one. Let's take that one. Let's clear it. So to put it on the top. So I'll do a retry. There you go. So now you'll see that retry takes a little longer, but now you'll see that now it became super fast. And the reason why it became super fast is not retrying anymore is because I have a circuit breaker that kicked in, and now it says, oh, this service is failing, so I'm not going to retry it anymore until I'm able to figure out that is back up. So if you look into some of the code that allows you to do this, so number service, so I have here, not the number service, yes, the number service. So that's on book. Should be here. Oh, there you go. So you'll see here there is the fallback, right? And the fallback just has a new class called fallback handler. You pass in whatever type you want to return, and then you just execute whatever logic. You can get timeout, which you can set up the timeout that you want. You have the bulkhead, which you set up the concurrent request that you want. And you have here the retry with the circuit breaker. So you say here there's a lot of parameters you can set up. So you'll say, what's the failure ratio after I should kick in the circuit breaker? What are the max retries that I can do? And there's a lot of other parameters that you can use to configure that in a proper way. So don't take those configurations as the ones that you should use, because I just use them for the presentation. So if I actually run the retry again, now you'll see that got a little bit delayed again because it's trying to retry. But since it was not able to make it, now it's going to be super fast again because it tried to retry. So the reason is there is this delay, which the circuit breaker is going to run. So then the circuit breaker say, okay, let's try it again. So then the retry kicks in. The retry is not able to make it, so the circuit breaker kicks in again, and now it starts failing fast again. And that's about fault tolerance. Okay, health checks. So now that we have everything running on our clouds, right, and have multiple nodes, it's super easy to have machines breaking up and machines not starting up. So we actually need to have a way to figure out if something is healthy and something is running and if something is doing the right thing. Now, the interesting thing about health check is you get a health endpoint for free when you deploy your application on a microprofile aware environment. So you have something called /health that you can call, and it will report you the health of the application. You can also implement your own health checks that are going to be called every time you call /health, and then it's going to pretty much do a concatenation of everything, and if one of them fails, then the entire health check fails. So if I go here on my, again, and I'm going to do a demo for this. So let's run the number. And so that's health. So you'll see there's a couple of other parameters over there, so don't mind them. That's just to make the output a little more pretty. Now if I call that one, I have down, even though my service is up. Let's see why. So actually what I did over here is I have, are you guys sleeping? I have a check audience isn't sleeping health check, which is random. Oh, there's a person over there that's sleeping. Oh, not sleeping, okay. But that's actually random. So let me call that one a few more times. So now that's down, now that's up. So you get the feeling. You can implement your own health checks, especially the ones that I usually tell people to implement is check if you have enough disk space, because people tend to have machines broken because they don't have disk space left. So that's the way to do it. And that's about health checks. So that's the way that you implement one. So you have the health check interface, you annotate it with health and an application scope bin, and then you can do whatever you want over there, and then the health check is going to be called when you call the /health. And that's an example. So metrics. So metrics also allow you to monitor essential properties of your system and to see how your system is behaving. Again, like health, there is a endpoint that gets added to your application as a standard way of Microprofile if you deploy your app on a Microprofile environment. So you have a slash matrix slash base for base matrix, a slash matrix slash application for application metrics, and vendor for vendor-specific metrics. So the ones that are standard are the slash base and slash application. Slash vendor depends on whatever servers you're running. And you can call these endpoints with options, and it will tell you what are it's kind of like a descriptor of what the metric is going to return. So what are the units that are being used, what's the type of the metrics, what's the description, and so on and so forth. So in here, if you call metrics base, usually you have standard information like thread counts, CPU, memory. Now in this particular example that I'm going to run, so I'm going to run a metrics endpoint over here. Okay, so I'm going to run that with application. So now you'll see I have a few metrics over here. I'm going to show them. Let's run base first. So if I run base, now you'll see you have class loader information, garbage collector information, memory, and the other one was application. Let's run that again. So if I show you my numbered resource again, you'll see there are a few annotations that I have over here called meters and timers, and what they're going to do is they're actually going to add metrics to that endpoint and going to report the metrics back to me when I call slash metrics. So one is going to basically do counting, and the other is going to do timing on that endpoint. So so if you see over here, you'll see that generate guest, that's the endpoint, are everything at zeros. So let's do a few curls over here for number. Where do I have number? Okay, there you go. So a few. There you go. So now if I call metrics again, now you'll see that I have. So I call the endpoint 4 times. I have the rates. So you have 15-minute rates, 5 minutes, the percentiles for 75, 50, 99. So on and so forth. And in here, you have also the count and the timings for how much time did it take to invoke the service. So you have a lot of useful information over here for your endpoints, just for free, just by adding a couple of annotations to your project. Okay, so let's keep going. So let's keep that one. So open tracing, So open tracing is something, for me, it's super useful because it allows you to trace the requests that you do from endpoints, right? Especially when you have all these services laying around and you want to figure out when something went wrong. How do you debug it? How do you see it? So open tracing is one of the ways to do it. So it allows you to trace all the requests that you do. So when you call one service and you call another and you call another, so it will trace all the stack trace call from all the services. So what's traced actually? So what we're tracing is JAX REST calls, so REST endpoints. And you can trace that, and then you can push that information to a database. Usually stuff like Zipkin are the most popular tools to push tracing information. So how do you do tracing? So tracing, you'll just do a add traces annotation, and that will say, okay, now I'm going to start do tracing for the entire endpoint. Or you can also inject a tracer with the ret inject, and then you can pick up the tracer and you can add your own information to the tracer. Maybe debug information, maybe some context information on what's happening. So I'm not going to do a Zipkin demo because that takes a while, but I'm going to do a different thing. So now I'm going to call my number again. So I call it through the book, right, from the book service. And if you look here on my log, you'll see here there is some tracing information, and you'll see there is a, let me see if I can put it on the top. You'll see there is a trace ID over there called 87, right? And there is a lot of information that's associated with that trace ID. Now, if I move to my number, you'll see again there is a trace ID 87 on the number API, again with context information. So basically what happened is there is a tracer that's propagating that context across all the endpoints, and that's the information that's being traced, that's the information that's being saved. And again, now you can pick up the information, save it to a database, and then you can see all the calls that were being performed on whatever service you've done, and at least it will be useful to debug and see what's happening. Okay, JOT propagation. So JOT propagation, who heard about JOTs before? Okay, most of you, wonderful. So also Microprofiles has a JOT implementation, and the JOT implementation allows you to propagate the security context across all your services. So it's just a lightweight way to do it. That's usually done as a JOT, and JOT is just a fancy JSON map with information that's signed with a private and public key that you can use to validate from your security provider or for your OAuth 2 gateway. So I'm going to skip about that, but the idea is with the JOT, you're able to say who's the caller, who's calling your service, what you can do, you can check roles, and how you can propagate that security context. And the idea with the JOT is it actually integrates with the security API that already exists on EE. So you can use the annotation, for instance, roles allows, and it will retrieve the roles from the JOT, and it will secure your API just by checking the roles that are coming on the JOT. Or if you want to retrieve information from the JOT, you can just yet inject. You can say claim value. You pass in the type of the claim, and on the claim you can say what's the property of the JSON map that you want to retrieve. So in that particular case, let's just say you have a JOT that has a username in there. You can retrieve it, you can inject it, and then you can use it. You can also inject the entire JOT with just inject JSON Web Token, so you have the entire JOT available for you. Or you can use the security context that you're probably already aware, and then you can do stuff like security context dot is user in role. You pass in the roles, and it will validate the roles that are coming on the JOT. The only thing that you have to do to activate this, so to say, is you have to use that login config annotation, and you have to annotate it with or set it up as an auth method microprofile -shot on your application on just RX application, and it will activate all the JOT propagation and all the JOT checks for your Microprofile app. Okay, OpenAPI. So OpenAPI, who's familiar with OpenAPI? Not that many. Swagger? A few more. So OpenAPI is the standard, is now the standard of Swagger. So Swagger is the implementation of OpenAPI, and it's a way to document REST services, right? So actually OpenAPI is based on Swagger too. So if you're familiar with Swagger, OpenAPI is very similar, and the annotations are also very similar. So the way you'll do it is, you of course, it will introspect the annotations that you already have, like the path and operation, or actually the path and the method, so to document your endpoint. Of course, that's not enough, right? So you have other annotations like operation and API response that you can use to populate that documentation. And again, a Microprofile OpenAPI gives that you for free. So if you deploy that on a Microprofile runtime, it will automatically generate a /OpenAPI endpoint for you. Even if you don't have those annotations, it will still infer whatever it can from your code. But again, what I'll do here is so let me clear that one. So I can come over here on the number API. I'll call it with OpenAPI, and I'll get a full descriptor of all my endpoints. So you'll see them. So you have number generate guest, and you'll see that's the get, that's the operationally generate guest. You have the responses, and so on and so forth. So that's a way to document your applications, and again, it's given for you for free. Finally, REST client. So REST client allows you to have a type-safe way to call other REST endpoints. So it's heavily inspired in Feign. So probably if you're familiar with Feign, it's very similar to what you're going to see over here. And extends the JAX-RS 2.0 APIs. So the way that you'll do this is you have an interface. You'll just create an interface that will map with the REST endpoint that you want to call. You use the same annotation to get paths, and then you have a REST client on the top. Now, after some magic, what you will do is you inject that interface with something called @inject and then REST client, and the server under the cover is going to generate the proxy code that's going to allow you to call the client API that you want to call, and you don't have to implement anything else. So just have the interface and do it, and then inject it on your class, and then you can call it. So, for instance, for people that are using Swagger, for instance, Swagger has a client that's able to generate interfaces from the Open API. So basically, you're able to go over there, generate the interfaces over the Open API. You can import it to your project, and then you can just inject them like that, and then you don't have to do anything else. Okay, so pretty much running out of time. So have a look into this project, startmicroprofile.io. So startmicroprofile.io, you can come over here. Basically, it's kind of like the boot starter that you have for Spring Boot. You can set up group ID, artifact ID. You can set whatever microprofile version that you want to use, whatever examples you want to use. You can say whatever servers you want to use. You hit download, and it will generate an entire app with all the samples, with all the right libraries, with all the entire dependencies for you that you can start coding and start using as an example for it. For future, Microprofile 3.0 is going to be available on June 2019, so we're already almost there, so maybe it's going to be delayed. It's going to be major updates for health and metrics, but there is also ideas to do stuff around GraphQL, long-running actions, concurrency, reactive messaging, event data, reactive relationship database access. So there's a lot of things that are happening on Microprofile right now. Get involved. So everything I show over here is public. Everything that you've seen over here is discussed over the mailing list. So you can actually drive the future of Microprofile if you get involved and you go to the list and say, hey, I want this feature, or I want to do this in this way, and you start collaborating, you start discussing with other people what's going to happen. Finally, resources. So microprofile.io is everything that's related to microprofiles over there. Tommy, server that I use, and all the samples that I showed are on my GitHub repo on Cortez/microprofile samples. And thank you so much for listening to me. I believe they don't have any time for QA, but I'll be around here, so please feel free to reach me out. I'll be happy to answer any of your questions that you have.